you, Vinisha. Let me just hit that button. Good evening and welcome to the second webinar organized by Biomimicry Switzerland in 2022. This is a part of a 5-series webinars of different applications of biomimicry in concrete settings. Last month, we talked about urban development and urban design. Today, we're talking about the seaweed industry. Next month, we'll talk about leadership and creating collaboration through a card game inspired by biomimicry. A few months ahead, we'll have laser applications and as well lessons for coaching from the African savanna. So we wish to include as many disciplines and countries as possible to cross-pollinate ideas. And this is where we stand now. And we welcome tonight Matthias Baumann, member of Biomimicry Switzerland Association, who is co-presenting tonight the solutions designed by SeaStem, a company they co-founded with 5 other people. And I think we're going to be ready to listen to lots of interesting facts about the seaweed industry. And I will let Eleanor and Matthias take it over from here. Just housekeeping, please save your questions for the end of each section. I will tell you when you can ask them, unless you have an urgent need to ask something. Otherwise, you can put it in the chat, and Vinisha, my colleague from Biomimicry Switzerland, will record these questions and serve them to us again. All right. Thank you very much. Thanks for being here. Matthias and Eleonore, the floor is yours.
Great. Well, thank you, Michaela, for the amazing introduction. And I already want to thank all the people involved in this webinar before I forget at the end and we wrap up and everyone is happy. So thank you a lot to Hugo and to Michaela, to Vinisha, and all the other members of Biomimicry Switzerland that helped spread the word for this this webinar. As Michaela introduced us, I'm Matthias Baumann, and this is Eleanor Wild. Together, along with 5 other highly motivated young former students, we co-founded SeaStem a couple of months ago. And so this is actually what we're going to talk about tonight. If I can change the slide. Let me just fix this. Always. Attends, si je fais ça. Bam, bam, and it's working. Awesome. As it is a webinar organized by Biomimicry Switzerland, as its name implies, of course, we're going to have a short introduction about biomimicry to make sure that everyone is on the same page for this. And then we'll just kickstart with what is SeaStem, and walk you through our journey, our short journey, if I may say, through the seaweed industry, and how do we apply biomimicry to make it more sustainable. So without any further ado, we'll start with a question to you, actually. If you be so kind to actually take out your smartphone, scan the QR code that will bring you to a Menti word cloud, or if you don't have your smartphone, you can just directly go to menti.com and use the code that is on the screen, which is the 1259146. It's highlighted in red. And then there you can answer the question, which is, well, what is the coolest organism? What's the organism you're looking at and you're like, damn, that's pretty nice. It can be either, I don't know, a tree, it can be an insect, a dolphin, whatever. And I was so kind to put a second choice, because if you can't make up your mind, if you have many other ideas, of course you can put your second favorite, and we'll see the result appearing here. And in the meantime, well, I'll ask Eleanor about your favorite animal.
I think I really like the greater auto butterfly, which has transparent wings. I would say that's my favorite one.
That was really specific. There's a morpho butterfly over there, right over your head. You can't see it, but it's also a pretty nice example. So what do we have? Flying squirrel. Well, that's pretty intense. Nice glass frog. fractals, that's also pretty cool. A lot of different, oh, octopus is actually quite a recurrent one.
We have coral, we have mushroom, sea otter.
Yeah, I hope I didn't bias anyone by putting the tardigrade on the picture, but I thought it was also a pretty cool organism, and it looks kind of strange, but it's super powerful. Mushroom is also a pretty pertinent one. Well, great. We'll keep an eye on this. Thanks for your input. So, if I may present to you my favorite animal, which is the mantis shrimp. Well, it's my favorite animal, not only because it looks super dope with all those colors and it has blue color, which is kind of unique in the animal kingdom. It has those super weird googly eyes that have far better vision than us, especially in the fact that they can see infrared vision, the infrared spectrum. But of course, you might know it. You might know this animal because of its super powerful punches. For those who don't know, this shrimp has the ability to break the shellfish shells. It has a punch that is as powerful as a small caliber bullet. And so it's kind of a condensed example of nature technology. And this is why I really like it. And this is kind of the where I started being amazed by nature during my biology bachelor. Every classes I was just like, well, this is amazing. Why isn't this not applied to human technology? And this brings us to the definition that I propose for biomimicry here, which is a way to emulate nature's genius on a wide range of size and complexity, in order to answer the technological challenges that we can find in engineering, in design, in architecture, and so on and so forth, in a regenerative way, but also, yeah, of course, design a new product that are also well integrated in their environment. Hearing this, some of you might think, well, okay, that's nice, but you know, we've been innovating by ourselves as a species for the last 200 to 300 centuries. You know, stepping foot on the moon, or you know, healing a lot of people, extending the life expectancy of our species, or even as it's more actual, exchanging a whole lot of data. So, aren't we the pinnacle of evolution? Well, that's kind of a biased vision. Let's put this in perspective. I quite enjoyed this image. I don't know if it's as clear as it is on my screen as it is on yours. If I may describe this, it's the storyline of evolution that is stretched on a 24-hour journey, where midnight is actually the present day. So here the idea is to appreciate the fact that our species is only a glimpse if you compare it to the whole timeline of evolution. Usually what is fun to do this when you're in presential, like meeting each other, is to do this on a piece of string that's 15 to 20 meters long, and then you can really appreciate the fact that all the previous species have way more experience than we have. And so the key takeaway message here is the fact that all the nature around us has been evolving solutions since far longer than we have. And so the idea is to tap into this this gold mine of innovation and adapted evolution to design the next product, or to solve engineering or again design problems. Here it is an example with car design that I think is pretty fun. If you look on the left, you have cars that are in let's call it an incremental fashion, always taking example on the generation of Ford that was designed by a human that himself tapped into the design of a previous human that also designed a car. Whereas on the right hand side, you have the attempts of a bio-inspired design car, where they answer the question, how does nature is more aerodynamic? In this case, it was hydrodynamism. With the fish is called a boxfish, and it has a bone structure that allows him to be far more hydrodynamic than other fish. And so they took the same bone structure to create a car frame. And then this is what this is a prototype they got. I'll give you that it might not be the best looking car, at least not in my opinion, but it shows the thought process and the comparison between human-inspired innovation and bio-inspired innovation. And to keep on this track, well, this is an example with car, but biomimicry is applicable to a super wide range. The application scope of biomimicry, sorry, is really wide, from nano to the ecosystem fluxes, or from basic engineering problem, or to extremely complex finance analysis of fluxes. Here are a couple examples that I found are pretty interesting. So you have those DNA nano construct developed by the Wyss Institute. I think they're in Boston, and so they're able to have targeted drug delivery using those DNA vessels. Then if you zoom out a bit and go to the more common sphere, then you have a bike frame that was designed by AP Works, mandated by Airbus. That was a couple of years ago already, but they basically use an algorithm that mimics the growth pattern of bones. So the thicker parts would be the parts where you have more mechanical constraints, where the thinner part is the opposite. All in all, it saves material and makes the bike 6 kilogram lighter, which allows the bike to consume less energy. And it's important because, as you might have noticed, it's an electric bike. If you keep zooming out, then you also have biomimicry applied to investment strategies. And so here the idea is that you have a global sense of the scope of application of biomimicry. And one last element that is maybe the most important one is the fact that emulation alone is not biomimicry. As Fabian, if you had the chance to be there, to be here last month, Fabian highlighted this pretty well when he said that, well, you have bio-inspired innovation, biomorphism, which is only the shape and not all the notion that are really key here. For instance, I'm talking about ethos and reconnect elements that combine with emulate, build a whole biomimicry design sphere. If you want to learn more about this, of course, you can Google Biomimicry Switzerland or the Biomimicry Institute. But just for the short definition here, when we talk about ethos, is the fact of consideration and respect for other species and the environment we're part of, and where reconnect is more the realization that we are part of nature as human, and that we should strengthen this relationship that we tend to forget. And so when those two elements are combined with emulate, well, then you have it. You have the proper biomimicry. So that's kind of the wrap up. It's a pretty subjective vision of biomimicry I'm aware of, and it's pretty short. We could do a whole webinar about this. For this part, I really hope that you got the essence and you got inspired, and well, you'll walk out of your house looking around at trees and be like, oh yeah, this is pretty nice. Look at that. So anyway, without any further ado, I will give the floor to Eleanor for the introduction about our young startup.
Yes, thank you, Matthias. So let me give you a quick overview of what is System and who is behind it. So System is an early-age startup that develops equipment for the post-harvesting treatment of seaweed. And our goal is to provide sustainable solutions for the seaweed industry. So what we try to do is to reduce the environmental impact and also the cost of seaweed production while maintaining a high-quality product. And that's what we want to do to help seaweed farmers. So we are a young team of 7 with background in biology and engineering. And what really brought us together is our common interest for bio-inspired design, but also our ambition to innovate for less impacting technologies. So now let me give you a bit of context about seaweed and why it is so awesome. So before that, let's go back 2 years ago in September 2020. When we wanted to get access to the Biomim Expo in Paris. And we actually found out that if we participated in the Bio-Inspired Challenge they had, we could access the expo for free. So we thought, well, why not create a team and submit a project. And this is where everything started for us. So at the beginning, we wanted to tackle the problem of stranded seaweed on beaches, which is a problem across the world. And throughout our research, we realized that actually seaweed is an extremely valuable resource with a lot of potential in diverse applications. So I'm also curious to know what you all think. And here is time for another poll. So the question I want to ask is, what is the first word that comes to your mind when you hear the word seaweed? So I invite you to go on the mentai.com website and enter the code if you haven't yet, or you can also directly access the poll by scanning the QR code here. And while you are all typing in your answers, I'm going to ask the question you, Matthias.
Oh, yes. How convenient. Thank you for asking.
So what's the first thing that pops into your mind when I tell you seaweed?
Well, I really don't like it when it rolls around my foot when I'm swimming in the sea. Like, this is like the worst feeling ever. I don't know. It's also super smelly. Like if you've been around beaches where seaweed were stranded, well, you smell it before you see it. So let's put it that way. So not a really positive view, except for sushi. Then it's fine. What about you?
Yeah, I agree. I have actually two words that come to my mind. As the first one is invasive, and the second one is sushi, as you said. So let's see what are your answers. So we have no answers yet.
I think apparently we're still on the old poll. Is this?
Sushi.
Sushi.
Now it's good.
Oh yeah, my
so
bad.
I think if you already typed your answer, could you maybe try to type it again so it's going to appear?
I like this one. If it's only this one, it's perfect.
Slimy. We have slimy, smelly, food, ocean, future food, cosmetic, weed, sea, weed. What else do we have? Coral reef, sustainable, interesting, nutrition, forest, Scotland, I see so somewhere.
Lichen is interesting.
Yeah. What else? Solar conductor. Let's wait 30 more seconds. Kelp, I saw kelp.
It's way more balanced, and I was expecting everyone to put something like, yeah, disgusting, smelly, slimy, whatever. But then looks like the audience is already pretty aware of the potential of seaweed, so that's pretty cool.
SpongeBob, I like this one. Carbon sink, that's very true.
Smelly sushi lichen. That could be the name of a band.
So, well, thank you for your answers, and I think we can move on. And so, yeah, I believe that globally, there can be a very different perception of seaweed, depending on culture or geographical location. Seaweed have been part of the Asian diet for a while, but a lot of people still have a very negative vision of seaweed. And I can tell that it was also my case. Because as you can see here, this is a photo I took during my holiday last year in Mexico. And this can really be a problem for coastal regions that are highly dependent on tourism. For me, it was just disturbing my day at the beach, but this can really be a bigger problem. And but however, this negative vision is evolving as we speak, because seaweed recognized nowadays as a superfood because it contains high level of minerals, vitamins, but also antioxidants and fibers. And here are just a few examples of what seaweed can contain. So seaweed are good for you, it's good for your health, but not only. It is also very beneficial for the environment and the marine ecosystem. For example, seaweed can capture carbon dioxide, and it can also absorb nutrients that are in excess in the ocean, like nitrogen or phosphates. And seaweed can also balance the pH of water, create habitat, and prevent coastal erosion. So more than a sustainable resource, it is a regenerative one. And as I was saying before, there is a wide range of applications in which you can use seaweed. For example, animal feed. So various studies have shown that a very specific type of red seaweed is able to decrease greenhouse gas emissions of methane, of cattle, sorry, especially methane. And for example, also seaweed extracts like agar or alginate can be used as hydrocolloids. So they are used as thickening agents in different products like jelly, candy, ice cream, or sauces to get the proper viscosity. But applications are not just limited to food. Seaweed extracts can also be used in cosmetics, as some people said in the poll before, or even biopackaging. And seaweed has really the potential to help shift from fossil plastic to bio-based plastic. So the key message I really want to say here is that seaweed is a resource with a lot of potential. And I will let Matthias continue with the current status of the industry.
Well, thanks, Ellie. It was really thorough. I think that we all learned something with this. And so to put back to put everyone back in the story now, because we've been through this research and we discovered this ourselves the same way some of you might discover this right now. And so we were like, well, we have an untapped, or at least not tapped enough resource on our hands. So how, what's the state of the industry around the world? What are we dealing with? So to give you an idea, the global production was in 2016 32 million tons for a market worth around $13 billion, which was mainly produced in Asia, where if you compare the 32 million tons globally produced with the 0.28 million tons produced in Europe, there's still a lot of work to be done to expand the industry in Europe. Last thing that you can notice here is the fact that it's expanding trends here. So we're looking at increasing an increase in seaweed production. And so this is for the global view. When we zoom in Europe, so this is also some work we did during our market research. We learned that actually the European market is evolving extremely fast and is expected to reach around 8 million tons of seaweed produced by the end of the decade. And this is mainly shown as well in the increase of European established seaweed companies that you can see here. It's almost 15% increase per year since 2012. Which brings the amount of seaweed producing units to around 250 now in Europe. So with that in mind, we keep digging and asking ourselves the question: well, how can we participate to this effort? How can we support this growing industry and make seaweed more present, whether it's in the cosmetic industry, in the food industry? How can we have a role to play here? Well, to do so, we started by learning how do we produce seaweed. Well, you might have guessed that first, of course, you need to cultivate the seaweed, or you can also harvest wild seaweed, which is sometimes a trend in Europe. But let's say that you cultivate your seaweed, it grows at sea, that's nice, but then you need to harvest it. So this requires some heavy equipment, some workforce to take out the seaweed from water, put it on a boat, and then bringing back to shore, where it goes under primary process. The primary process is mainly washing, cutting, and stabilizing the seaweed. As it will be explained shortly, the stabilization of seaweed is one of the key bottlenecks in the industry. However, here, as you may have noticed from the two dotted lines, you can already sell the seaweed either raw, like just after they've been harvested, or you can also sell them right after they've been stabilized, so either frozen or fermented or dried. Finally, the secondary process are all the methods that extract the bioactive compounds or hydrocolloids from the biomass. And so we kept on diving into the seaweed industry, and what we realized is in fact that all these steps are not equally optimized in Europe. And we stumbled upon an extremely interesting article that was published last year. If you have the occasion to take a look, I highly suggest that you take a look at this. It was written by a Norwegian seaweed researcher, and they did an extended survey amongst many different stakeholders, especially seaweed farmers in Europe. And what came out is the fact that the all that comes from harvesting and processing is not optimized at all. It's not homogeneous. No one is doing the same way, and there's still a lot of room for optimization for these processes in Europe. And especially when it comes to stabilization. If you remember, stabilization is it's the step right after you took out the seaweed out of the water. Because what we don't realize is the fact that as soon as you take seaweed out of the ocean, well, you have a window of 24 to 48 hours where it needs to be stabilized, because otherwise it starts to rot, and then, well, you lose your product. How it's done now, again, according to the study, mainly is fermentation, because fermentation is cheap and is pretty efficient. You can have those used vats, and then you just put the algae inside with some other ingredients, and then the lactic acid fermentation takes place. However, it doesn't confer that long of a shelf life. Here it's written 8 weeks at 4 degrees, which is not really optimal. And also during the fermentation process, some key components are destroyed, namely hydrocolloids, which highly decreases the value of the final product. The two other approaches for seaweed stabilization is freezing and drying. Of course, freezing, well, it's extremely energy intensive, and then you need to keep the cold chain all along. So the last option that we identified was namely drying. And to us, we thought that this was the best trade-off between shelf life, which is here in this case 2 years room temperature, and bioactive compounds preservation. So that means that when you dry seaweed, you can just conserve them in a way that is logistically more relevant, and you don't lose any value. So then we kept digging and identified the fact that, well, in Europe, the situation is quite ambivalent. So either you have people still drying seaweeds on lines. We had an interview with a stakeholder, one of the biggest producer in Norway. They harvest around 300 tons of seaweed, and some of this seaweed, not all the production, they still hang them in warehouses like laundry, and they flip them by hand. So that was pretty interesting for us, because, well, we saw the opportunity here to have a better solution. Because on the other end of the spectrum, people, some of the stakeholders are using super heavy and bulky and energy and cost-intensive machinery that are on top of this, not even optimized for seaweed. Is what you can see on the bottom left of your screen. They don't look all like this, but this gives you an idea of the volume it takes and how not flexible it is. And so with that in mind, so we identified the problem, which was seaweed drying, and thus we started looking on, okay, how can we propose a novel, or at least fill the gap into the supply chain, of course in a sustainable way. And so here, before we dive into biomimicry and how we applied it, I'm just going to have a few slides to give an introduction about solar drying, because this is the approach that we decided to take to dry the biomass. Of course, solar drying, as its name implies, is the process of using solar energy to dry your biomass. However, it's different from sun drying, where the biomass is merely just on the plastic covers and dried directly in the open air, where solar drying is slightly more refined, where the biomass is contained into an hermetic drying chamber that can be in the direct type transparent. So as it's pretty well explained on the slide, well, the sun dries, the sun brings the energy to warm up the air and also to dehumidify the product. However, note that here the biomass is exposed to UV light, which can be a problem in certain cases. Another common approach is the indirect solar drying type, where here the drying chamber is opaque, so it doesn't have any transparent cover, so the product inside is shielded from UV rays. And then you notice those tubings, this parallel area of tubes. This is the solar collector. So this is where the air warming up happens thanks to solar radiation. So then the warm air is tapped into the drying chamber where the drying occurs. And finally, you have well, the mixed type, which is just the combination of both previously mentioned equipment. And so here we then decided to give our own version of solar drying with this equipment. So yeah, it was not designed by Jeff Bezos, don't worry. Even though it looks a bit like his rockets. This is one of the comments we had whenever we would present this. Yeah, just to highlight the fact that this is it's an illustration, it's a 3D rendering. We haven't built this, and we're still pretty far from it, but it's a way to illustrate what we want to do. On this picture, you can see at the bottom those glass tubes. So this is the solar collector. So if you remember, in the indirect solar drying types, you had like those parallel tubes. So this is, well, kind of the same idea here, except that you notice that inside you have different structures. And if we look a bit closer, well, here is where biomimicry happens, or at least where we aim to implement it. So in these tubes, you will have structures that will be described by Eleanor in a few seconds, where the air is dehumidified and is heated up. Then it enters the drying chamber at the bottom and works its way up through the different drying trays where the seaweed would lay drying. Again, this is a concept. We are well aware that it has many flaws, and we just started prototyping, and it doesn't look anything like that. But well, the idea is here. I mean, so we use biomimicry to leverage on technical aspects of solar drying. So when we were doing our literature research about solar drying, we identified key leverage points that we could use biomimicry on. And that was namely solar radiation absorption, airflux management, and air humidity removal. So with that in mind, we pivoted and asked ourselves, well, how does nature optimizes the solar radiation absorption, or how does nature creates air fluxes, et cetera, et cetera. And this was actually the really fun part, because then we saw a lot of different organisms and brainstormed. And well, Elena will walk you through our brain thought here.
Yes, so I guess it's time to ask nature and see how we can learn from it. So the first organism we took inspiration from is the moth. And it's an amazing insect because it has anti-reflective eyes. So the eyes are able to prevent light reflection, and therefore the moth can avoid being detected by predators. So typically light reflection happens when there is a change of medium and a difference of refractive index. But here, the moth eyes is composed of a nanostructure that has a gradient of refractive index. And so the light is not reflected, but instead it is all captured by the eye. And so if we go back to our solar harvester, solar dryer, what we want to do is to optimize the harvesting of solar radiation. So then we thought of implementing this strategy by having an anti-reflective surface so that we could maximize solar absorption. And this has already existing applications. For example, that allows to maximize the transmittance of light. And here you can see an example with the two pictures. So on the left, you have just a standard glass, so you can see the car, but you can also see the effect of reflection. And on the second image, you can see the car way more clearly without this effect, because on the glass, there was the coating was put on both surfaces of the glass. And it is a coating that is inspired from the moth eye. We also took inspiration from a beetle, the Hercules beetle. So it is an insect that can be found in rainforest of South America. And the Hercules beetle has found a very smart way to change its body color to adapt to the surrounding environment and remain hidden from predators. So during rainy days, the beetle is black and it turns to a greenish color on sunny days. So let's try to understand how this works. So the beetle has a cuticle, which is composed of a network of chitin filaments, creating open pores. And during sunny days, these pores are filled with air. And there's a very big difference of refractive index. And so this creates a multi-layer interference. And this is the reason why we see the green color. Now, on more humid days, the pores are filled with water, which has a very similar refractive index compared to chitin. And so the beetle appears black because there is no light reflection. So again, we want to mimic this strategy because for our solar dryer, we want to have the air that is as dry as possible to be able to dry seaweed. So we need to have a system of moisture absorption. And we thought of having this type of microporous membrane that could act as a super absorbent structure and be able to remove the air moisture from the airflux. And again, there are some existing applications like this super absorbent hydrogel chamber, which can be used in buildings to dehumidify airstream. And so if you're interested, I invite you to look at this scientific article to know more about it. And finally, the camel, that's my favorite one. So as you know, the camel lives in the desert, which is a very hot and dry environment. And in order to survive, it needs to find water in whatever way it can. So the camel has a nose that is able to absorb water molecules from the air while it's breathing. So let's see how this is possible. So first of all, the nasal cavities are very hygroscopic. So it means it can absorb water very easily. And the reason why it is so efficient is because the nasal cavities have a spiral shape, as you can see on this image, which is a cross-section of the camel nose. And by having this spiral shape, it maximizes the surface area between the air and the camel. So it enhances heat transfer, and therefore water condensation can happen inside the nose of the camel. So here again, we thought that this was a very interesting strategy. And we were thinking also to use it to dehumidify the air. And instead of having just a simple monolayer condensation tube, we could have a multi-layer condensation tube to maximize the air contact. And so these are 3 strategies that we have started investigating, but of course, we're always looking for more.
Exactly. Well, thanks for the explanation. I hope it might be a bit technical for some. Of course, if you have questions, we'd be happy to give even precision or to extend a bit more the explanation on these aspects. But here again, the key takeaway message is that we want to have a dry and warm airstream that enters the drying chamber, and those are like the main biological strategies that we kept. And so, on a really practical aspect, here's the timeline to locate a bit where we are now. So we could say the starting point of this project was when we submitted this design to the Biomimicry Global Design Challenge in last June, for which we were selected amongst the best top 10 teams, and we were invited to participate to a launch that lasted December 2021, where we had the occasion to lay the foundation of our project to start an extended market research in listing technical assumptions, etc. So the very first step of this project. Now we started 2022 full of energy and motivation because we finally started prototyping, which was extremely exciting. Well, we will see where it leads. We're still building our network and looking for technical support and for some technical feedback as well. But of course, because it wouldn't be fun without this, we need we're still looking for funding, and we're applying to a dozen of different incubator or funding program, which at least in Switzerland we're pretty well supported on that aspect with all the different kind of funding channel that exist. So yeah, we're still at the beginning of this adventure, and hungry for more, and to look. We're gonna push this project as far as we can, and see where it leads. But of course, as we are still pretty new to this field, what matters here is what do you think after hearing this this short presentation? I don't know if you have still room to to think about a comment, but we would be happy to hear what's your feedback here.
All right, thank you very much, Matthias and Eleanor. I learned so much today. I'm happy that I could attend this because I saw your presentation before, but there's so much more value in hearing you talk about it. I think we have a few questions. Vinisha, maybe you want to come, and then we'll do the feedback on your project from the participants. Is that okay with you?
Of course.
Vinisha?
Yes, I'm here. You just can't see me, I guess. So from what I've been tracking in the chat, the first question from Jason Bell goes, does seaweed grow very fast like bamboo? And how is there so much of it all over the world all the time? And
so seaweed growth depends on the latitude. For instance, we were in contact with stakeholders that have a project in Morocco, and there they can harvest 7 to 8 times a year. Whereas in Norway, it's only 1 or 2 per year. So it really depends on where you are on the planet, and also, of course, of the seaweed species, because something that we didn't put too much emphasis on is the fact that we're talking about seaweed, and seaweed by extension means macroalgae by opposition to microalgae. So microalgae would be chlorella, spirulina, those monocellular organisms. And so we are focused on seaweed. So just want to make this clear. I don't know if that answers the question or.
I don't know if Jason's still with us. The next question's from Annika. I'm not sure if she's still with us, but her question was, what is the primary use for European Union seaweed?
It's mainly food, feed, and cosmetics. The bioplastic is starting to grow, but it's still under development. The company that we showed earlier, Bezos, is actually growing pretty fast, but it's still, they're kind of the only one doing this in Europe right now. So yeah, mainly food, and also biostimulants is growing in some parts. I think in the Netherlands, and I don't want to say any other. In France, I think the biostimulant sourced from seaweed is also growing, but yeah, mainly food.
Next question's from Michaela, actually. Do you just want to unmute and ask?
You kind of answered this
Okay.
partially right now. I was saying, is there lakeweed? You know, like freshwater seaweed, because we're in Biomimicry Switzerland, we don't have a seashore. Is there applications for algae growing in our lakes?
Well, that's actually pretty fun that you ask, and that was definitely not staged at all for everyone else, because there is actually a company called Avalgo based here in Lausanne. Lausanne is next to Geneva on the shore of, well, sadly, the Geneva Lake. We don't like to call it that way, but anyway. So on this big lake, there's a company that harvests seaweed, but they're wild seaweed. So there's no seaweed culture, in, at least not that I know of, in freshwater. And actually, it's interesting because we're going to reach out again for Avalgo, for this Lausanne-based company, to see if we could gather some samples, at least to have an idea of how the seaweed reacts to our first prototype.
Excellent, thank you.
Okay, we have the chat buzzing with questions. So first I'm going to request Adfase to just unmute yourself and go ahead with your questions.
Well, thank you very much. It's a very interesting topic, and thank you very much for this interesting presentation. How come that a Swiss firm, so you're not related to the sea, come to work with seaweed?
Yeah, that's well, it was a bit random, as we explained in the beginning of the presentation. It was because we were looking for a challenge to solve. And then during a brainstorm session, someone mentioned the seaweed stranding on beaches, and this is the starting point. Also, something to highlight here is the fact that out of 7 team members, only 3 are based in Switzerland. We have some people in Lisbon, in Brussels, in Amsterdam, and in Croatia. But yeah, it might sound a bit paradoxical that, yeah, of course, Switzerland doesn't have any access to sea, at least not that I know of. And we are trying
well,
to.
I like paradoxes and the diversity. If I put my email address in the chat, and I would like to be in contact with you after this or meeting or maybe later this week. I live in Zeeland, which is a province in the Netherlands, and we have a kind of seaweed culture, and there is a group of people who are dealing with seaweed. I don't know yet how they deal with it, but maybe it's good to get into contact. And the next thing is if you have interest in doing something in the Baltic Sea, I might be able to bring you in contact with other people as well.
Well, thank you for this input. Of course, we'll stay in touch. We'll make sure to get your email address, and we'll send you an email, of course.
Yeah.
Actually, yeah, we can even communicate in Dutch, because one of our team member, is from Amsterdam and living in Amsterdam, so that will even facilitate the communication. And
okay, yeah, but
thank you
because that's easier to communicate for me. I have a solution. I might have a solution which might be interesting for you, to dry seaweed with the combination of high speed and sound.
Okay, so like centrifugal forces with ultrasound.
Yep. And it seems to be very cost effective. So let's be in touch. Thank you very much.
Thank you for your input.
Okay, could I request Lily to please unmute yourself and ask your question? We don't hear you.
Yeah, sorry, I was looking for it. Thank you for the presentation. That was super interesting. I'm actually in the Netherlands as well, and I'm doing anthropological research on seaweed. So that was really interesting. And I was wondering if you're mostly in contact with stakeholders or also with seaweed farmers, and also if you focus mostly on the European seaweed industry or also worldwide, like what's the scale?
So far, we aim for Europe, from Portugal to Norway, with, of course, in mind the fact that the first version of our prototype might work better in southern latitudes, of course, where there's more sun. So I was mentioning a Moroccan-based project, so we might as well start there and then work our way up. But in the big picture, of course, the Atlantic coast of Europe. And we've been in contact with both seaweed farmers and also seaweed transforming actors along the value chain. And interestingly, we were also contacted by people that are definitely not related to the seaweed industry, but that were really interested in the drying mechanism. So since drying, of course, is a really transverse problematic, or at least aspects in the agri-food business, well, it's also interesting for us to see if it can be applied to any other field, drying tobacco or drying any seeds. Ultimately, the goal is to lower the energy consumption, because if you might have noticed on the previous slide, it takes around 5,000 kilowatts to dry 1 ton of dries about 700 kilo of water. So that's a lot of energy. And if you can tap at least a bit of it in sunlight, well, that's already energy that is saved.
Okay, thank you very much.
Pleasure.
Okay, next we have questions from Elizabeth. Is she with us? May I request Elizabeth to unmute herself if she's here? I don't see her. Okay, her question was, does seaweed have cleaning properties such as absorption of toxic elements, heavy metals, and water pollution?
Yeah, and that's actually kind of a problem, because if it has this super absorbent, not super absorbent, but it absorbs the excess of nutrients. And sometimes if it's near a polluted area, well, it's good because it harnesses some harmful metal or like other compounds. Then it's not in the environment, but then the seaweed itself to be consumed might be problematic, if that was the question for the cleaning. Otherwise, if it's real cleaning like detergent or this, I'm not really sure.
She isn't here for a follow-up question, so let me request Katrina to unmute herself and ask her question, if she would like to. Katrina. Okay, her question was, have you considered harvesting invasive species?
She's
Sorry.
on.
Hello. Wait,
Hi, Katrina.
I think they can see it. There you go. Yes, your question.
Yes, Katrina.
Hi, yes. We live in New York State, and hydrilla, I don't know if you're familiar with that. It is an invasive water, like seaweed type product. And so I'm just wondering, is there any potential to, combat this invasive species by finding, some market for it?
Yeah, well, that's I don't know the species for sure. The person who's more focused into the different seaweed species unfortunately cannot be here tonight. However, this makes me think about the Sargassum problem in Mexico, where they actively try to find a way to valorize the seaweed, because then they would there would be more attraction to remove it from the beaches. And I guess this is kind of the same problem, but that I'm aware of. I don't really know the species, and I'm not really sure that there is right now at least a structure or any process to valorize this, but that would be definitely an extremely interesting idea.
Yeah, it's freshwater. It's not really a seaweed, but it's a weed that grows very fast in the water, and it can get into people's props, for boating, and so it grows like a couple inches a day, I believe. Mm-hmm. So it's very problematic once it begins in a water body.
Yeah, and also for the other organism, because it taps into the oxygen reserve of the water, mm-hmm. of the water environment it's in, and so I assume it's killing also other vegetables or fishes, like it has been shown in some tropical region or other where we have invasive seaweed species.
Yes. Well, thank you. Very interesting talk today.
Thank you. Roger, would you like to unmute yourself and ask your questions?
Yes, thank you. I think you missed my question earlier on. I don't understand just how seaweed is cultivated. I mean, I can understand how it grows and mm-hmm. how it is harvested, but cultivating it sounds a little bit more active, and mm-hmm. I also wonder whether if it is how it is once it is cultivated, whether you've done any impact assessments on the environmental impact assessment.
Well, that's a really good question, because we've been going over the subject of cultivation pretty fast, when it actually took us quite a while to understand all the different aspects. To answer directly your last question about the impact assessment, no, we haven't done anything such, because it requires a lot of work, and right now we are mainly focusing on prototyping and getting funded. But to extend a bit more on the first part of your question, which was how is seaweed cultivated? Well, yeah, I'm really glad you asked this one, because here on this slide that I've run a bit fast over it, on the far then you have it's a stream with seedlings of seaweed. So seaweed, as like the regular plants, they have roots, even though they're not called that way, but let's put it that way. So they have roots that need to be anchored in a medium, which is called like a growth support. And to do this, so they incubate the seedlings on these ropes for 2 to 3 weeks into a controlled condition, into some kind of labs, some kind of incubator. And once those seedlings have matured enough to be anchored into this tiny piece of string, then they go at sea and they wrap this piece of string around a larger rope that then they deploy into different shapes and different fashion into the ocean. So each seaweed farms have their own way. You know, some only have like simple lines, some have system with different levels. And so then, as I answered in a previous question, the seaweed grow between, it takes between 1 and 3 months, depending on the latitude. Once it's ready to be harvested, then they go again at sea, and they, with again very different processes, they take the seaweed out, cut it, wash it, and then again all the steps also depends on the final application and what kind of seaweed producing unit we're talking about. But overall, this is how it's done.
Thank you.
My pleasure.
Next, Monica, you could go ahead and ask your question.
Yes, thank you. Hello. Well, thank you for sharing. I know the project because I was in the Biomimicry Global, I am jury, but I am very sad because I think that is the last one global challenge, you know that? So you have to enjoy it. So, no, after the, we are in Argentina, so we have a lot of seaweed and not a lot of sun, but some kind of sun also. But we are just beginning a building project at home. And we were investigating, you understand what I mean? The building construction. Do you think that this kind of material we can use in the building material, for building materials? Or your goal is to harvest and the distribution and to dry, but not for what is the material afterwards? What do you think?
Well, I think that's a question that Eli might have some idea, or at least an estimation. But just to clarify something, right now we're only focused on seaweed drying, proposing the equipment and maybe the workforce or the knowledge that comes with. We're not taking the seaweed, drying it, and then selling the seaweed. We're mainly focused on the solution itself. Regarding the material, well, Eli, who's got a master in materials, maybe you have an idea. I don't know if there are any compounds in seaweed or something that can be used to, besides plastic.
No, I would say the most would be plastic, bioplastics, I think, but this is not what we're trying to do. We're really only trying to dry the seaweed in a proper way and treat it to be able to pass it on to the downstream processes. So
for
yeah,
any company that needs the seaweed.
Yes, exactly. Only. Yes, our goal is not to sell an end product made out of seaweed.
No, I understand. Okay.
I mean, maybe the cellulose, I'm not sure about the percentage of cellulose you would have in seaweed, because I was thinking while Elena was answering, I don't know if you heard about I don't remember the name, but there's this guy who recycles cellulose from kombucha, and then he does this kind of, it's kind of similarly wood. So maybe you could do the same with seaweed, and then just manage to isolate the cellulose and then have some kind of a building material.
No, I know examples in UK. They use in the sail, I forgot in English. Well, for the top of the home.
The roof.
The roof, yes. the material, and it's okay, not so much, but they do 2 buildings like this. So I think that is the new material. I am thinking also a little question, and after I to another person. This is bio-utilization well adapted, no? Like the ecovative, like the fungi. You understand what I mean? Because you take care about that, no? That we have to something to take from nature, but we have to take care about that also. You understand what I mean?
Yeah, I heard bio-utilization. Was that correct?
Okay. Yes. Okay.
Yeah, no, it's that's why it's a regenerative resource. Because by cultivating seaweed, then you have like this really regenerative impact on the local environment.
Okay. Because not to take. Okay. Perfect. Thank you.
Like any other resource, like anything, I want to say in life here, too much of anything is bad, you know.
Yes, I know. Because of that, I know.
Yeah, but I think that the tipping point where it becomes bad for the environment is a bit further down, further up than if you compare, for instance, to biofuels with colza oil, when you know it just shifts the problem to another realm. When with seaweed, it seems that there is a bit more of margin to absorb the demand for hydrocolloids, for food, for feed that are gonna grow. We expect to reach 9 billion people by the end of the century.
Yes, it's amazing. The algae, I am in love with algae. So I think that is the future. The microalgae and the macroalgae. Yes, we are researching that. So we keep in touch. Thank you so much.
All right. In the interest of time, let's move on. We had a question from Andrew. If he would still like to ask his question. Andrew?
Yeah, hi. Loved the presentation, loved the examples of the organisms that you presented. And I put my hand down because a couple questions I felt like were just answered. I was curious about applications for plastic substitute for like plastic wrapping using seaweed. And you kind of said you're not looking to do that sort of thing. So then my other question was, how hyper specific is this solution to seaweed? And would it be applicable to other industrial practices? Or are you just focusing on seaweed now and hoping to expand, or just keeping it there?
Yeah, thank you for your remark and your question. The first choice. So we're targeting seaweed right now, but also willing to broaden the horizon of possibility for the air treatment units, because the air treatment unit is something that can be easily optimized with bio-inspired strategies. The main difference between seaweed and other product to dry is the fact mainly just the water content in itself. And also the fact that you have alginates in the seaweed, in most species, that then make the seaweed react in a different way when it's drying. There are other aspects such as the porosity gradient that changes between seaweed and other bio-based product that you would like to dry. Again, as I mentioned earlier, we were also contacted by actors in different fields that were interested in the drying technology. So the way we're gonna work forward now is both focusing on the air treatment units and also on the drying chamber, that both need to be optimized. But yeah, we are well aware that we could apply the this air treatment unit to for other application than only seaweed.
And I think it would be a matter of changing the parameters.
So when you said that you weren't looking to sell a product, so to speak, that was seaweed, is Seastem a tech company developing those types of technological products to sell?
Yeah, we would sell the hardware with a revenue model that would be either the rental with a service fee, or just to sell the product in itself, maybe with some consumable being embedded, such as the microporous membrane. We were thinking of having the same color change that the Hercules beetle shows, so then the users know when the membrane is filled. But yeah, this is also still work in progress. It will depend highly on the final volume of seaweed that we're able to process. Because right now, for the prototype, we're aiming only for a shy 500 kilograms of seaweed per batch, which of course we aim to optimize. But the idea is not to treat the whole production of a seaweed production. I mean, the whole production of a seaweed producing unit, because they have up until 300 tons of biomaterial to dry, and then it would be at least where we are now, it would be a bit too challenging. But at least to redirect a stream of their production to increase the value and see from there if we can keep scaling up. So yeah, this is kind of the perspective that we have now.
Thank you.
Thank you for your question.
Okay, do we have any more questions? It's an open discussion now. Or else I could just quickly introduce the next webinar and we'll come back to see if anyone has questions.
Well, just to continue my question from before, this is Jason about there was the first question about, I forgot what it was.
The bamboo?
Yeah. So it grows like very fast, right? So if let's say everyone started using it and realized it was a great resource, and what you said, would it not run out, or does it grow very fast? Like because coal, there's been coal in the earth for like millions and billions of years, but seaweed, I don't know how much of it there is, but we use a lot of plastic and a lot of stuff like that, and food, if we use it for more food, plastic, yada yada yada.
Yeah. What would happen if the demand just explodes, and then we need to produce a lot of seaweed? That's mainly the question on, is it?
Yeah. Sorry. Yeah.
All right. Yeah. Well, I think it also depends on the amount of nutrients that you have in water, because I think that would be one of the limiting factors. This and water temperature, and also maybe the streams. If you have heavy streams where in the cultivation site, that might also hinder the production. But again, we're not expert in seaweed production, unfortunately. Because we had to divide our time equally between production, processing, etc. But if I would like to take the guess that the limiting factors would be mostly nutrients, water temperature, and the kind of algae you want to grow. But it would be interesting to do projection and estimation about what would be the maximum production, because then you would also have you would highly increase the carbon sequestration, and that could be also interesting with the whole carbon credits market and everything. But that's another topic.
Yeah. Okay. Thank you.
Thank you.
I think, Venetia, you should introduce next month's webinar now.
Just a short, quick one. If you could go to the last slide, please, Matthias. I think it should be. Yeah. Okay, to those of you still tuned in, next month we have Dr. Marina Ruta, a member of Biomimicry Switzerland too. She works at the World Economic Forum as the lead for the Biodiversities by 2030 initiative. And as a biomimicry practitioner, she has more than 10 years of experience in facilitating multi-stakeholder partnerships. So in this webinar, Marina will guide us through the fundamentals of innovation through biomimicry, but she's also going to present how she used these fundamentals to develop a tool to help facilitate partnerships and to create safe spaces for collaboration. Where she got this inspiration was from the mutualistic association between fungi and trees, if you're familiar with the root network systems in the forests. So this also led her to create Mycelium, which is a fun and inspirational game that allows for creative conversations amongst different stakeholders and to help them reflect on their own partnership journey. So if you are curious about biomimicry, if you are curious about social innovation and how biomimicry can facilitate social innovation, do come and join us at our next webinar. We'll be opening registrations early in March. So that's it. Over to you, Michaela and Matthias.
Thank you very much, Vinisha, for this great introduction to the brave next speaker on our webinar series. Thank you to Matthias, thank you to Eleanor, thank you to everyone for your questions, for your inputs. There's lots of things in the chat. There's lots of people who want to connect with you at CSTEM and put their network at your knees. So that's fantastic. Very happy to have been able to kind of hold the space for that. Thanks to all the organizers, Biomimicry Switzerland, for creating this series, and of course, for your interest. So you know that everybody needs money to live. If you would like to fund Biomimicry Switzerland in order to continue these webinar series, I think Vinisha is going to post a little link in the description. And so see you next month. Thanks, everyone. And don't forget to fill out the questionnaire. This helps us to improve from one webinar to the next. Very happy to have been here with you, and talk to you soon.
Thank you, Michaela.
Thanks everyone for
Bye.
listening.
Thank you. Thank you so much.
Where do we find the questionnaire?
Thanks. I can share it again. Yeah, and I
Okay,
will
sorry.
be,
I didn't see.
yeah, sorry. I'll also share it via email once the event is done. So,
Okay.
Thank you.
but I will share it right now again. So, thank you.